Okay. All right. Virtual students, you're used to this. My classroom face-to-face kids, I'm not there today. Be on your best behavior. All right. Pay attention to this. I hate that I'm having to miss, but I didn't have a choice. All right. What we're going to do today is write equations, linear equations, based on real world problems. All right. So if you are whenever we have slope intercept form, we're going to use it when well use when given a rate of change, which is your slope, and a starting point. And this will make more sense when we go into problems, okay? All right, so this first problem, and y'all should have copies of these notes, all right, these guided notes. So be sure and write down as we go along, all right? Let's see. Evan's going to the county fair this weekend. The admission to the fair is $5, and the cost per ride is 50 cents. All right, so he has to pay $5 just to get in the gate. Doesn't matter if he rides 10 rides or no rides. Okay? He's got to pay that $5. All right, so that's kind of like that's going to be your starting point. All right, so he has to pay the $5. So we're going to say that this is our B, our y-intercept. All right, and then he has to pay 50 cents per ride. Okay, it says if his parents gave him $20, write and solve a linear equation to find how many rides. Okay, so as we talked about before, when you look at the last sentence of a word problem, it's telling you what you're going to have to give, and it's usually what you're defining your variable as. So we're going to say that x equals the number of rides, because it's how many rides. So we're going to be solving for x. All right, so how many rides? It's 50 cents per ride, and per means multiply, right? So I would say y equals my rate of change is 50 cents per ride. So 50 cents x plus the $5 I have to pay regardless. Okay? So this is my equation, but I already know that y, which is my total cost I'm having to pay, the parents are going to give you $50. I mean $50, $20. All right, so I know that y is 20, and it's 50 cents per ride. So we're going to solve for x. So isolate the variable x. All right, so minus 5. So 15 equals 0.50x. And if we're going to divide by 0.50 on both sides, x will equal 30. So he could do 30 rides. Okay? All right, let's look at the next one. And when you're doing your answer, put a box around it and make sure that you're telling what that represents. Okay? All right. While visiting Crimson Lake, Sally decided to go kayaking. The rangers charged $8.50 per hour in addition to a $25 deposit to rent the kayak. All right. If she rented the kayak from 11:30 a.m. until 2:30 p.m., write and solve a linear equation to find the total cost to rent. All right, so our total cost to rent. So Y is going to be our total cost. And we know that she has to pay the $25 deposit. And usually, y'all, when you see the word deposit, that's going to be your B, your y-intercept. All right, and it's $8.50 per hour. So 8.50 per hour x. Okay, so we know how many hours she's going to do from 11:30 to 2:30. So 11:30, 12:30, 1:30, 2:30. So it's 3 hours. So our total cost will be $8.50 times x is the number of hours, right? So 3 hours plus 25. Okay? So we're going to have y equals, if you multiply that out and add 25, your total cost is going to be $50.50. Total cost. All right. So when you're doing these if they have you a fixed cost or like a fixed deposit, a fixed cost, anything that's a one-time fee or upfront cost, those are going to be the B, the y-intercept. Y equals mx plus b. That's going to be your B. And then when it's something per hour or something per day, that's going to be your slope, your rate of change. Okay? All right. Let's look at number 3. Okay, Alex bought a new truck for $42,935. According to the dealer, the truck will depreciate approximately $4,200 a year, $4,200 a year. So depreciate is going down, right? It says write and solve a linear equation to find out how many years until the truck is worth $5,135. All right, so we know our rate of change because it says per year. So our slope is it's decreasing, so it's negative 4,200. All right, because it's decreasing. And let me all right, so your slope is negative 4,200. And your y-intercept, your B, what do you think that's going to be? All right, this is your fixed cost. This is what it started out as. Okay, I know that one's a little bit different, but that's your starting point. Okay, so remember up here at your notes, we said when you're given a rate of change and a starting point. All right, so it could be a starting point, and these fixed costs and deposits, those are all starting points. Okay. All right, so our starting point, and this is per year, so X, our starting point was 42,935. All right, so we want to know how many years, so we got to solve for X to find out when it's going to be 5,135, $5,135. So that's going to be our Y. So now we're just going to solve, so we're going to subtract 42,935, and then you'll get negative 4200x equals, and you're going to have a negative number. Don't worry about it. Okay, it's going to be negative 37800. Then we divide by negative 4200, so x equals 9. All right, so what do you think it's going to be? 9 what? well, we said how many years, right? So it's 9 years. Okay, because it's 4,200 per year, so X is years. Okay, all right, I'm going to leave number 4 for you, another practice problem that you can have. If you buy a car wash at the gas station, it's $6, and then the cost per gallon is $2.35. So you got your fixed your cost and what you're spending. Okay, so it's kind of that one's going to be kind of like number 1. Okay. All right, so let's look at standard form. All right, standard form you're going to use when the problem relates to different objects. Okay? Okay. This one says Sam ordered 2 hamburgers and 3 hot dogs from the concession stand at the baseball game. His bill came to $19.05. So his total cost was $19.05. Okay? That's his total. If the hamburger costs $5.25 each, all right, so it's $5.25 per hamburger. Write and solve a linear equation to find the cost of each hot dog. All right, so let's say that X equals the number of hamburgers, because we have 2 different objects here, and Y is going to be the number of hot dogs. Okay, so we know that he bought 2 hamburgers, plus he bought 3 hot dogs for a total of $19.05. Okay, so I know that is the situation. Now, I can't solve for 2 variables. I can only solve for 1 variable. So I need to know, if they want us to know the hot dogs, number of hot dogs, we're going to be solving for Y. So I need to know what X is. So he bought 2 hot dogs at $5.25 each. So we're going to take 2 and we're going to substitute X with $5.25 plus 3Y equals $19.05. Alright, so 2 times $5.25 would be $10.50 plus 3Y equals $19.05. So we're going to subtract $10.50. Alright, so 3Y equals 18. Oh, not 18, 8.55, right? Alright, so 8.55, so I need to divide by 3. So Y equals $2.85. Okay, so it's $2.85 for what? What is Y? Hot dogs, right? So the hot dogs were $2.85 each. Okay. All right, let's look at the next page over. Okay. Number 6. Tickets at a school play cost $4 in advance and $5 at the door. Total ticket sales for an evening production were $440. If no tickets were sold in advance, write and solve a linear equation to find how many were sold at the door. All right, so we got two different objects here, two different cases. We sold tickets at the door and we sold tickets in advance. All right, so that's going to be our two variables. All right, because we need to know how many tickets. So we're going to say that X is the number of advance tickets, and that Y is going to be the number of tickets at the door. Okay? So we know that you're charging $4 for advance, so 4 times X, plus $5 per ticket at the door, so 5 times Y. And their total sales were $440. Okay? So this is money, this is money, this is money. All right, so it said if no tickets were sold in advance, how many were sold at the door? So we're going to be solving for the number of tickets sold at the door. And they told us that X was 0. So $4 times 0 plus $5 times Y equals 440. All right, so 4 times 0 is 0. So we're just going to divide by 5. So Y equals 88. All right, and Y is number of tickets sold at the door. So we sold 88 tickets at the door. Okay. All right, let's look at number 7. Karen's piggy bank has all dimes and quarters. The total value of the money in her piggy bank was $11.40. If Karen has 36 quarters, write and solve a linear equation to find the number of dimes. All right, so let's say that X is the number of quarters and Y is number of dimes. Okay, and it comes to a total. So if we're adding those together, you're adding your quarters plus your dimes, and you have a total of $11.40. Right? Okay, but the thing is, we don't have anything here. How much are the quarters worth? 25 cents, right? Because we're dealing with money here. So then you need to put 0.25 times the number of quarters. That'll give you how much money is in quarters, right? And then for dimes, I'm going to have to multiply the number of dimes times 0.110, 10 cents. Okay? So that one was a little bit different. You had to know to put that amount. They were giving you amounts here saying they were dimes and quarters. All right, so there's our situation. And they said if we sold 36 quarters, how many dimes? So we're solving for the number of dimes. So we're solving for Y. So we need to plug in 36 for X, the number of quarters. Okay. All right, so all right, so 0.25 times 36 is, so you had $9 in quarters plus your dimes. All right, so we're going to subtract the $9. So 0.10y equals $2.40. Now we're going to divide by 0.10. So y equals 24. So that means we had 24 dimes. Okay. All right, and I'm going to go ahead and do number 8 also because these are a little bit trickier and you've got plenty of practice on those. Okay, the Oakville High School Marching Band sold gift wrap to earn money for a band trip. Solid paper sells for $3.50 per row, and then printed gift wrap sells for $5 per row. The band needs to earn, so it needs to earn $2,500. If the band sells 325 rolls of printed, then write an equation to find out the number of solid papers that they must sell. Okay? So we're going to say that X is printed and Y is solid. Okay? So let's write our situation. We got two different types of paper. $3.50 per roll for solid. All right, so it's $3.50 for solid. So $3.50 times Y plus $5 per row for printed. And X is printed, so 5 times X. And we want it to come up to $2,500. Okay? So it says, so this is our situation, right? So it says if we sell 325 rolls of printed, so X is printed, so we're going to substitute 325 for the number of printed rolls. And we're going to solve for Y, right? Because we need to know the number of solid rolls. All right? So let's work this out. 350 Y plus, let's see, 5 times 325 is 1625 equals 2,500. So now we're going to subtract 1625. Okay, it's 2,500 minus 1625. So we got 3.50. Let me put that minus. This is minus 1625. Y equals 875. So now we're going to divide that by 350. So Y equals 250. Alright, so 250, y'all, I'm sorry. Y is 250, so that means 250 solid paper rolls. Okay? Alright, y'all have an individual practice. Look at your notes while you do the practice, okay? Work it out. Remember to identify by naming what it is your answer is. Don't just give me the number. Tell me what it is. Okay? All right. Y'all be good. And I will definitely be there Thursday. All right. Thanks, y'all. Have a good day.